Well, guess we're going to get started. Thank you so much for coming. My name is Peter Heinrich. I'm the last name on the list. I'm a developer evangelist with Amazon, and I mostly focus on games. And today, Mike Builder and Evan Jacover from Jackbox Games are going to give you kind of the backstage tour of Quiplash, which is a multiplayer game that's super fun to play because it does such an amazing job of engaging players and spectators at scale. So they're going to give you the story of how Jackbox Games brought Quiplash to life. But before I turn it over to them, I want to briefly just touch on one aspect of achieving their level of success in this age of esports and Twitch TV. And I also want to take a moment to mention that following this talk, we're actually going to be giving away a bunch of Amazon devices. And the way you can participate is by scanning your badge when you come in, which you've done already, so you're already entered. And then at the end of the presentation, we're going to announce the winners through a website. So we'll put up the bit.ly link that you can find the results. So as Mike and Evan are going to make clear in a moment, Jackbox Games is right at the forefront of a whole new kind of interaction model. That is, they're designing these games that are designed to be played in really big public ways, and they really blur the line between the player and the spectator. They're using broadcast media, they're using individual mobile devices, they're obviously using AWS, and they're tapping into a brand new kind of fan base, one which is highly engaged. It's an audience that is just as important, really, as the players themselves, and they participate in a lot of the same ways. This combination is a really powerful one because it has such potential, but it does require a slightly different kind of thinking when it comes to engagement and business model. So at Amazon, of course, our business depends on your business. So we have a vested interest in making you guys successful, and that's why we think it's really important to share this kind of sea change in perspective toward multiplayer game development. And we're also really thankful for Jackbox Games allowing Mike and Evan to come and describe the specifics of their situation and their experience with Quiplash. So I love foosball. It could be singles, it could be doubles. I'm actually pretty good, so if you think you can take me, then at the party tonight, let's do a little throwdown. But regardless, the reason I mention it is because foosball is the perfect example of a player's game. Right? I have fun, I make time for it, sometimes at work. Don't mention that. Oh, I see some people from Amazon. Don't mention that back home. And I have friends that will make time to play with me. But foosball does not really engage an audience, right? It doesn't appeal to fans the way it does to the players. Not like this game, which I think is even maybe loosely based on foosball. But look at the amount of fun in this picture, right? Look at the amount of revenue in this picture. The fans here outnumber players 1,000 to 1, and that's just in the stadium. The business opportunities have obviously expanded as well. And you think about all the monetization that's happening here. There's the hot dog vendor, the jersey maker, the commentators. They've all built entire businesses around the game. And the whole process generates increased excitement, right? It has the effect of lowering the cost of getting more people involved and also providing a steady stream of engaging content. So what's the difference? How do you take your game from foosball to football? How does your game make that leap from pastime to passion? Well, we think it involves expanding our notion of the MVP. This is the minimum viable product. We're all familiar with these pieces in the middle. But to support the new fan base, there are some additional components we think that enter the picture. So the first component is building support for influencers. These are the people who get in early, they try it out, they actually show other players the fun, they kind of spread the word about what's happening. And these folks are the ones that experiment with your game as well. They explore it. They're kind of key to introducing it to the mainstream, the wider audience, because they're the ones that are describing what the game is all about. And they come in different shapes and sizes. The best ones, of course, are the ones that advocate for you. So they could be players or spectators. These are the people who are so excited about the game that they're actually willing to create, or maybe they're driven to create something new to express that feeling. It could be fan art. So for example, in this case, this is Annie and her bear Tibbers from League of Legends. And Riot Games, the developer, celebrates this. They welcome these creations, and they actually put them on display. There's a whole gallery online of this kind of art. An influencer can also be a professional, which might be a broadcaster or a journalist or a league player who makes a living playing games or commenting on them. So Rainad27, for example, is a prominent Twitch TV broadcaster. He has about 210,000 viewers, 18 million views. It's pretty phenomenal. And it's not possible for everyone to have connections like Rainad27, but if you have the resources to connect with someone like that, then you can tap directly into their network. And this Hearthstone event actually drew about 250,000 viewers with a total of 10 million minutes watched. And of course, there are regular celebrities. For example, PewDiePie, right at the top of this list. He's the #1 subscribed channel on YouTube, even ahead of YouTube itself. And he posted a little video of himself playing a game called Flappy Bird back in January of 2013. And I think we know what happened with that game. That video got 25 million views, which certainly contributed to the explosion of Flappy Bird's fan base. So this is an example of somebody who's a real celebrity. Somebody, could be a movie star, could be a musician, or a YouTuber like PewDiePie, and they get hold of your game, and it just goes crazy. Okay, great. So what's the second strategic way to build on the basics and foster this new fan base? Well, it's content creation. You want to enable people to make content using your game as a base, which will lead to a greater variety of user experiences and longer lasting content. And as far as content creators go, there are a few classifications that are important to us. The first is the entertainer. So they're going to take your core content, they build their own content on top of it. So for example, I showed you PewDiePie. He kind of freaks out about stuff. He's very physical online, and he's just kind of entertaining to watch. So I also mentioned he's the #1 subscribed channel on YouTube. So he gets a lot of attention for what he does. Another popular area of content creation is based on education. So these creators basically say, I will teach you how to play Hearthstone, or I will teach you how to play League of Legends, or build a better deck, or figure out strategy. They'll break down the nuances of the game and help you succeed as a player. So there's another reason to watch. One is, I like to be entertained, it's fun to watch. Another is, I'm coming to this because I want to learn something. And then there's all this content generated around esports, electronic sports, which is just exploding around us. And for all of those who are, let's say, 30 and above, you could see me afterwards, I'll explain it to you. But there are these events that are becoming full-blown media extravaganzas, and there are commentators and color commentators, announcers and color commentators, and they're just the same roles that you would see in a regular sporting event. They walk you through the play-by-play, they tell you all about the participants, they explain the strategies and the tactics, and they create a whole ecosystem of content around the event. Other content creators focus on expanding the game itself. They add levels or skins or characters. And so for example, Minecraft, as the perfect example, there's been so much added to that game that you could essentially play forever and never see repeated content. When a new movie comes out, someone will create a mod for it. If you want to play Hunger Games in Minecraft, you can do that. It exists. And finally, I mentioned before, League of Legends fan art could also take the form of fan fiction. This is just a really cool way for people to connect with each other and express their enthusiasm for the game. Okay, so the last piece of this puzzle, extending the MVP to support this new fan base, is finding a way to generate alternative revenue. And when I say that, I'm talking about revenue for you, but I'm also talking about revenue for your players and fans. And again, this is revenue outside of your core monetization loop. There are really tons of ways to take this fun in a new direction. You could do crowdfunding or merchandise. You can do alternative media or advertising, esports, of course, as I mentioned. But a major benefit of generating revenue outside of your app is this opportunity to expand your fan base. So somebody buys a t-shirt with your logo on it, and then people can see that. And somebody else might say, huh, wow, what a cool concept. I love that logo. Where'd you get it? When is the game coming out? Where can I obtain it? This is just such a great way to expand your reach and your impact. So we've identified these 3 areas that we can explore to expand the basic MVP, supporting the influencers, encouraging content creation, creating revenue opportunities outside of your core game loop. And we think this expanded view will help you achieve more than just a minimum viable product and actually lead you to developing a minimum viable business. Yeah. And with that, I'd like to turn things over to Mike Builder from Jackbox Games. He's going to discuss the practical implications of reaching this new fan base and achieving achievement on a grand scale. And you'll also see with Quiplash how they've applied some of these ideas, put them in motion to great effect. So, thanks, Mike.
Thanks, Peter. So I'm going to give you a quick little rundown. I don't know how familiar everybody is here with Jackbox Games, but we used to be called Jellyvision Games. We've been around for quite a while. And we're best known for this title, You Don't Know Jack. Some people may know it's a successful running trivia title. It's been around since 1995. But we grow tired of making You Don't Know Jack, and so we expand into other areas. And we put some effort into a mobile game called Lie Swatter. Can I actually kill? Yeah, thanks. But a lot of you probably don't know Lie Swatter because nobody really bought it. So, but because nobody bought it, we try to come up with ways to reuse all the effort we put into it, the art assets, the trivia content. And the way it worked was it was a simple true or false type game. It brought up a bunch of facts. You would swat the bugs, swat the lies, basically. And in this case, I'll give you an example. True or false, an astronaut smuggled a corned beef sandwich into space. So how many people think that's true? Okay. It is true. So there was an astronaut named Walter Schirra who snuck it on the first Gemini space mission in 1965. But we decided to take Lie Swatter and do an experiment with it. And the result of that kind of changed the direction of the company forever. We took Lie Swatter and we made a version that would play up on the big screen. So we took it to a theater in Chicago called the Music Box, and they happened to be showing a midnight performance of Christmas Vacation around the holidays. And before the movie came on, we let all of the audience members play along. So people would take out their phone, and they would simply go to a website, jackbox.tv, and they would enter the 4-digit code that shows up on the game and their name, and then they were playing along. So the phone has a contextual changed buttons now for truth or lie. And it was just a very different experience. It's up now on the large screen. And here's another one. So you have to guess if this is a real Kanye West tweet, which is, as soon as I'm off this jet, I'm a rent. We bought a zoo on Redbox. So how many people think that's a true Kanye West tweet? Not many. Well, you're correct. That's a lie. But what we saw was a ton of people having a lot of fun playing games, laughing and joking. I mean, this guy loves it. So we decided, these are the type of games we want to make. We always wanted to make party games. That's what we're good at. And this is a great format to do it in. So we took that knowledge, and that led to the creation of the Jackbox Party Pack, which was a collection of 5 party games. They work in the exact same way as this original Lie Swatter demo. So the game's up on the main screen. Everybody can take out their mobile phone, their tablet, anything with a web browser, laptop, and join the game and play. And we put it out on just about every system you can think of: consoles, PC, Mac, set-top boxes, including Fire TV and the Fire TV stick. And we even got Lie Swatter in there, too. But after we launched this, what we didn't realize and what we didn't expect was people were going to stream it. And not just stream it in broadcasting their play and trying to entertain their audience, but using it as a means of multiplayer. So people would actually launch a game. They'd tweet out the room code, and it didn't matter where you were. You logged into Twitch to watch the stream, and you joined on your device, and you could play along. And so we realized now we need to kind of focus on this. This is actually a great thing for us and a great thing for large multiplayer experiences. So we kickstarted a game called Quiplash, and if anyone here backed our Kickstarter, thank you very much. Thank you very much, appreciate it. And we added a feature called Audience Play, and that's what we're going to talk about and demonstrate today. Like many of our games, Quiplash supports up to 8 players, so there's the lobby screen that comes up, and 8 people can locally join the game and play. And as they join, same way, you take out the phone and you go to the website. As they join and the room fills up, we unlock the audience mode. So after the game has started, or in this case, while you're still sitting in the lobby screen, up to 10,000 people can join the audience and play along. And this has been very successful and popular with large streamers. As you can imagine, this is a more interactive way to actually entertain those folks. And the way the game works, to give you an example, multiple people are paired up, so everybody has to answer a quip. When you first log in, you're given 2 questions to answer. So in this case, the quip was the hit song from the Broadway musical, Fart the Musical. And 2 people, Evan and Spencer, have entered in their 2 answers. Those are then brought up side by side. The remainder of the players in the game vote on their favorite one, and the audience votes as well, and they can actually sway the vote.
It's weird that no one voted for me, though. That's unusual.
Yeah, right. Evan didn't get a lot of votes there. So what we're going to do is switch over to the game and just show it to you quickly.
Wait. I'm going to start it first. So
Okay,
people don't try.
start it first.
Okay.
Okay, so we started the game already, but you can still join as an audience member. So if you take out your phone and go to jackbox.tv, that code in the upper right-hand corner, that's how you join.
All right, feeling good, you guys? Well, we'll see if we can fix that. Let's go. This is round 1. You'll see 2 prompts on your device. Answer them any way you want. Each answer will go up against someone else's answer, and everyone will vote on which they like most. It's simple. You score based on the percentage of players who like your answer. Plus, there are winners' bonuses at stake. Go.
So this is a point of filler for all the broadcasters right now because there's nothing for the audience to do. But everyone that's participating in the game has 2 prompts on their phone now that they have to answer. Okay, so as each person enters their 2 quips, they'll come up. And some other things we added to the game that's different from some of the games in Party Pack is we added a family-friendly filter because some streamers and some people that played at home with their kids were asking for us to call out the worst content that we have.
Let's take a look.
And we added extended timers
things
to get
off.
around some of the delays of Twitch
Not
and other
very
streaming
scary
sites.
name for a pirate. Okay, pick your favorite.
Okay, so now everyone should be able to vote. You can see the audience counts going up. You guys are all playing. And in the mode, you can turn on extended timers or not, so that allows the timer to actually tick all the way down to 0, which gives plenty of time for the audience members to get their votes in. If we disable that, as soon as all the active players put their answer in, it will proceed with the game. It'll be a faster experience. All right, so Peter sweeps the vote there. We'll show you one more.
And next, a better name for the game Duck, Duck, Goose. It's voting time.
Nice. Oh, easy, easy. We're from Chicago. All right. So you get the idea of how the game proceeds and how the game works. We have many games based on the same thing. We're actually launching Party Pack 2, which is another new collection of games next week. So it'll be out on Fire TV and a number of other devices. All right, I'll take it. So that's the idea. So I'm going to switch back to the presentation now. And, oh, sorry, guys. All right, here, you want to see what that is? Diaper? I wouldn't order diaper. Okay. Can't stop it. I can stop it. Okay, so back to the presentation. I'm going to turn it over to Evan, who's going to tell you all about the technology of how this stuff works. So, Evan.
Thanks, Mike. All right. So I'm going to kind of take you on kind of a journey through our whole, the last couple years at Jackbox Games and our successes and failures. We are a bunch of game developers. We don't really employ any systems engineers, and I think it kind of speaks to AWS that we were able to pull this off without knowing what we're doing. I'm going to just kind of a little preview of what we are going to cover. So I'm going to talk about the controllers, how we use your phone and tablet to interact with games running on a console. We'll go through the server architecture, talk about how we went through the tuning and optimization process on our server infrastructure. And I'll go into how we implemented this audience feature for Quiplash, and finally how we scale our servers up and down based on a number of factors. So starting with controllers. Before we made Quiplash or Fibbage, we actually made a version of You Don't Know Jack. It was a launch title on the Amazon Fire TV in the Ouya.
Nice.
And since 4 Fire TV controllers would have cost way more than the box itself cost, we didn't think it was likely that people would have a whole bunch of controllers. And we didn't want them to have that. We wanted this to be an easy game to play. So we made an Android and iOS app called the Jackpad. And it worked as a controller. It had 4 buttons, and you could play the game with it. But there were a few problems that we found with Jackpad. For one, you needed to install an app, and that's just the worst. If you're sitting around with a group of people and everyone's going to their app stores and trying to remember their password because they're your dad and he always forgets his password, it's just a big roadblock to getting into the game. Second, everyone needed to be on the same Wi-Fi connection, same Wi-Fi network, which is also troublesome. Again, if you're at my parents' house, they're flipping over their router, trying to read off the number. And third, there's always that one person with a Windows phone or still has a BlackBerry, and it's just not worth our time to make apps for all these different devices, great though they may be. So as we moved on to make more games, we wanted a different, easier solution. And so the first thing was, instead of an app, we made a website. You've all just used it. It's jackbox.tv. It works in any browser. We've seen people use their Nintendo DS browser, whatever that is, to play the game because they're weird, but it works. And it's a very frictionless operation. You can imagine if we were trying to get all of you on the same Wi-Fi network and download an app and do what we just did. Instead, you get your 4-letter code, put it in, and everyone's playing the game. So we call this system Blobcast, just because it needed a name, and it will kind of make sense why it got that name. So that's the controllers. A side effect of this approach is that instead of a peer-to-peer connection where the controllers are connected directly to the game, we needed servers to facilitate communication between the game and the controllers. So we started building out the architecture. And that first demo we did at the Music Box Theater was very simple. It was one EC2 instance. It was running Node.js, socket IO for the connections. We had a console or a PC. It could be anything, the game host. And it connects via socket IO to the EC2 instance, sends a message, I want to create a room, and it gets a response. Here's your room, it's been created, here's the room code. And then similarly, our game controller, which is a mobile app, can also send a message, connect via socket IO to the same server, say I want to join the room with this particular room code, and gets the response, you've joined the room. And once we have that connection in place, we can bounce messages back and forth between these two, all these devices. And we have a very simple API to facilitate this, and this is where the name Blobcast came from. We're really just updating a number of JSON blobs between the two. So the host can alter a room blob, which just contains state information about that particular game. It could also set a customer blob, which is state information for a particular customer. And the game controller itself can send messages back to the room owner. And that's it. That's the entirety of our API, or it was. And it was nice because you'll notice there's no game code in this at all. And it allowed us to very rapidly make a whole bunch of different games on the same servers. You know, we could just unleash a game developer and they would make a game, and we didn't need to do any server updates or anything. It would just work. So that was our initial architecture. As we started to release games to more than a theater full of people, we realized we needed more servers and we needed to be able to scale. So we started to have several EC2 instances in our cloud and different room codes running on each one, and this makes things a little more complicated because when a controller comes along and says, I want to join this room, it needs to first know which server to connect to that is hosting that particular game. And similarly, when a game wants to create a room, it needs to know which server to connect to that has the most availability. And so we added a RESTful API on top of the Socket.io application. So when these connections come along, they can first query the system and ask what room is QWOP on, and it's on the server named HoHo. And I want to start a new game, and the cluster will respond. Churro is the best server to start a new game on. It has the least amount of connections currently. So each of our instances is running two servers. It's running an HTTP server and a Socket.io server, and we have secure and insecure ports for each of these. We're hoping eventually to make it all secure, but some of the platforms that we wanted to run our game on didn't support that at the time. So we support both, and that's how the game works. So we have, just to kind of fill out the architecture here, there's an elastic load balancer that's in front of all the instances, and that distributes the initial REST API requests across all of the servers. So as we scale up to support more socket connections, we're also scaling up those servers as well. It's worked out well for us now. At some point, we may want to separate those concerns and scale them separately, but that hasn't been an issue for us yet. And on the back end, we use Redis to manage room reservations and server status. We don't really care about all of our data is ephemeral. Like if a server goes down, if a game ends, we don't really care. We're not tracking user data. These are party games. We want you to just get in and get out. We don't want you to have to log in. And so Redis has been great for that. It's very efficient. It does reads and writes very quickly. And also its data types have come in very handy and allowed us to implement new features very quickly, which has been great. And just to give a quick example, when a server comes along and wants to create a new room, it needs to ask which server to create that on. And we use sorted sets in Redis. And so we're constantly updating the sorted set with the load for that particular server, which is kind of our own concoction of different variables of what makes up how much load the server is under. But generally, games and connections play a big part of it. And then when we need to go and get the next server for a new game, it's just whatever's at the top of the list is the best server. And that's a very fast operation in Redis. Just a quick digression here. If you're ever dealing with these 4-letter room codes, sometimes unexpected 4-letter words can come up. It could be fun. It could be ironic. But it could also be a disaster, and we didn't have anything in place for this, really. We now have a blacklist of terrible, terrible words. And the brainstorm for this was just the worst hour of a lot of people ask us why we don't just eliminate vowels and like kind of solve this problem once and for all, but it's kind of too fun when the funny ones come up, so we're choosing to do it this way. Okay. So tuning and optimizing our servers. This is something, I came to AWS a couple years ago, and everyone was talking about like choose your instance types correctly, and I was like, whatever, let's just pick one and make it work. But here I am now saying choose your instance types correctly, because it does make a big difference and it saves you money. And we're a small shop, and saving a little money can make a big difference for us. So we need to learn a couple things about our game and how it worked. How many games and players can run on a single instance? We had no idea. What's the most efficient instance type? How are we CPU bound? Are we IO bound or memory? We had no idea. We didn't know what was more cost effective if we had 4 large servers or one XXL server. We needed to learn. We needed to gather information. So we started to do that. The first thing we did was just started playing a bunch of games, and we quickly learned that we needed to tune our servers better. And this was days of trial and error, and then I went to a talk a couple months ago, and someone was like, "Here's what you do: just do this, and it will be great." And so I'm kind of passing that along here. Tuning the Linux kernel will drastically change how many connections you can support. Just out of the box, AWS Linux only supported 1,000 connections at least a year ago when we were looking at this. So this was immediately gave us way more connections. Then we needed to start doing some tests of our own. And we wanted kind of a real world simulation. We wanted something that would accurately represent what it would look like when a bunch of people were playing. So we wrote a script that plays the game, which seemed like a good place to start. It looks for specific game states. Our API is very simple, so it didn't have a lot to look at. So it's looking at those room blobs and customer blobs and then responding in a way that makes sense for that particular game. And we have one of these for every game we make. And then we could just run that script thousands of times and monitor the servers and see what happens. So we used an application called Bees with Machine Guns, which actually was introduced to me by Brad, who's here. So thanks. In the documentation, it says the bees are more or less a distributed denial of service attack in a fancy package, which might be overstating it a little bit because the package is not very fancy. But you can see some of the commands here. There's a fork of it, which is down there, that lets you execute kind of arbitrary shell commands on these bees, which are micro instances. So the first command, bees up, just starts up 10. This is starting up 10 micro instances. You give it an AMI, so you can have some pre-baked stuff on there that's useful, which we do. We have kind of a base application on there, and Git and Node and all that stuff. So we can just run a git pull and npm install, and that will have the latest version of our tester. And then we tell it to run our little tester app and play Quiplash with 1,000 users on each of these bees and what room code to connect to, and they all connect and just start playing the game, and we can watch the game and see what happens. And you could even join in as a player and kind of play along with them, which is boring because they don't really put in anything particularly interesting. But this gave us a ton of insight. We were able to run a bunch of these tests and watch our servers and see what happened. So here's just kind of some data. We were looking at instance types here. And we found that we were generally CPU bound, which makes sense, I suppose. We're not sending a bunch of traffic, but we have a lot of connections, sending very little data. So we were kind of looking at this worst case CPU, which is like, what's a moment in the game when all of the connected players or audience members are sending information at once, or when they're all joining the game. What's happening in those moments? And this kind of follows it as we add more and more players. And we learned a couple things. One is that, unsurprisingly, the compute optimized instances did the best. And so if we take out the non-compute optimized ones, we saw a huge improvement going from C3 to C4s, which is not surprising. It's also partly because our C3s were using paravirtualization instead of HBM, and they didn't have enhanced networking turn on. And so both of those things, I'm guessing, make much as big have as big an effect as just the improved processors. It's also interesting to note that C4 X large didn't provide that much of an improvement. That's actually not that surprising given how Node.js works. So Node.js is single-threaded for the most part, and so we'd have to spawn off, fork different processes to take advantage of these bigger instances. So that's a project for us in the future. Right now, we're just rolling with C4 larges, and they've been pretty efficient. So with Quiplash, that was kind of where we were when we started making Quiplash. And with Quiplash, we wanted to introduce this new audience feature, which we hadn't done in any of our previous games. So big streamers, they could get upwards of 30,000 live viewers. And that's more than a single server can support. So we needed to have multiple users, users spanning servers at this point, spanning instances, all playing the same game. And so we needed to change how our servers worked a little bit. So our first attempt at this was using Redis PubSub. And it worked great in all of our little small-scale tests. But under heavy loads, which was specifically when Lyric, who's a very large Twitch streamer, decided to test out the game, we noticed that these subscribe sagas would occasionally just disappear. And we didn't have any code in place to reconnect them. And we're like, oh, we can monitor them and reestablish the connection. But all of that kind of seemed like too much work. And so we just kind of switched to using queue polling. Which ended up being way more efficient. And this is kind of where Redis shines, is doing a bunch of reads very quickly. Since it's only each server instance polling, we don't have millions of servers. We have a handful of servers instances. And so this worked out really well. And we're introducing a little bit of latency here. But that's something we're OK with, especially for people in the audience, because our games are designed around that. They're designed for where you don't need to push a button to jump over some lava. It's a bunch of people sitting around in a room, distracted by a bunch of different things, and we want it to be more of a casual game. And so, thinking about how your users are interacting kind of gives you some leeway to think about creative solutions technically. Communication goes both ways too. So all the servers can send messages back to the host and vice versa. Since the vast majority of our games are still played in a room with some friends at a party with 8 or fewer players, we didn't want them to have a worse experience just so we could support these rare games with thousands of players. We put a couple of caveats in here. For one, we didn't want to add latency for regular players. So we don't switch over into this multi-instance mode of hosting a game until there's at least 100 players in the room or 100 audience members. And then at that point, they start joining additional instances. And we start up that intra-instance communication. We also wanted to make sure there's no single bottleneck. So there's no part of this game that can fail just because there's a whole bunch of users. But we actually have a single bottleneck here, and it's the instance that's hosting the game. So when 10,000 audience members are all playing Quiplash and they all vote under this architecture, they're all sending a message to the host, which is then processing that message and sending a result back to everyone. And so even though everyone's communicating via socket with separate instances, all of those messages are going through the queue, the Redis queue, to one single instance that has to process them. So that was a problem. We wanted to get rid of that. So we've kind of started building up a library of efficient functions. And the first one was voting. And we're, again, leveraging Redis for this because it has these great data types that really let us efficiently do some things. So when we create games can now create a new voting session, which creates a couple objects in Redis. One is a set of user IDs who have voted, so we can ensure that they're not voting multiple times. And the second is a hash with votes that we're kind of just incrementing. And all of those actions are very fast in Redis. So we're validating new users, and then we accept their vote by adding them to the user list of voters and incrementing whatever they voted for. And so this way, the host instance is just checking in with Redis to see the latest state of the vote instead of processing all those votes itself. So we're leaning on Redis for a lot. Yes, and then finally, so the game can query the vote state just by pulling down that hash for its room. Okay, so finally, I want to talk a little bit about scaling. We use OpsWorks, which solves a lot of problems for us. With one click, we can add another EC2 instance to the cluster, and we get a lot of stuff set up for free. It sets up Node, tunes the Linux instances, creates DNS entries in Route 53, and it enables the service in Redis so that the rest of the cluster is aware of it, adds it to the load balancer, and then we have custom chef scripts that are setting everything else up, which is great. But we don't want to have to click a button when we want to scale up or down, especially since a lot of our scaling tends to happen on holidays, and I don't want to sit there on Thanksgiving, checking and adding servers. So a lot of people ask us why we don't use OpsWorks to auto-scale our instances. We don't. And we could do some of the stuff. We could set up CloudWatch to monitor our connections and scale up, which would work great. Scaling down is a little trickier, though, because when an instance shuts down, everyone connected to it gets disconnected. So we need to let all of the games hosted on that particular instance end, like all the games playing Quiplash on that instance need to end before we can shut it down. And that means we can't really scale down based on averages. We need to scale down by the actual number of connections on a specific instance. So we need to look at a little bit more information. So we made our own auto-scaler, which is just a cron job, although now that Lambda supports timed events, we maybe will switch over to that. And it does a couple things. So it's querying OpsWorks and Redis to get the current state of what instances are running on OpsWorks, and it looks at Redis to see the connections and our load calculation for each instance. Then we can start up and disable servers based on that data. And we also, we use two metrics for that. One is time of day. Our users have a very predictable pattern. No one plays on Monday mornings. A lot of people play on Saturday nights. A lot of people play on holidays. So we can spin up servers preemptively for that. And then we can also add servers based on just the actual load. If servers if we have too much capacity, we can disable a server. We don't actually shut it down. We just mark it as disabled. It's still running, and all the games keep playing on that server, but no new games are added to it. And we let those servers drain until there's no more games, no more connections, and then we can actually shut down that server. We also do a couple checks as long as we're in there. We connect to it via all of the different ports we have open, make sure that those are all working. If one of those is not working, we put that server into the disabled state until we can check on it. So it's still running. If it is somehow working, but something's malfunctioning, at least the games keep going, but no new games will be added to it. So we disable servers that fail those tests. When we released Quiplash, we realized that a big audience, audiences follow different scaling patterns than a bunch of 8-person games, which is what we had seen before that. A stream with thousands of viewers, if you have 10,000 viewers, they can all join that game within seconds. You put up the room code, and you have all these people, and they just type it in and join. And so we have a whole bunch of new connections, and scaling up our servers is too slow for that. It takes a couple of minutes to add new instances, and so we needed to come up with something else. So we split up the audience onto their own set of instances, which gives us a couple things. We can always keep 10,000 connections or 20,000 connection capacity available, and then scale up. Since we know that game can only have 10,000 maximum, at least we have time to scale up before another crazy streamer with 1 million viewers streams the game. And the regular games can scale slower because it's only 8 players at a time maximum, and so we have some more leeway there. And it's also nice that a big audience can't hurt people playing the game, small games that are running. So what's next? We're looking to leveraging regions for geographic speed. Right now, everything's running out of Virginia, which was fine when we were just a North American release, but we've since released in Australia and Europe, and So Australia's far away. I mentioned multi-core support for our server, our node application. We'll look into that using Lambda for auto-scaling, so we can get rid of that one server that's running that all the time. And better analytics, which is something we've been kind of toying with for a while, but there's a lot more we can do with that. So we have a little bit more time. I'm going to quickly go through, that's it for our server architecture, but I want to talk a little bit about the Fire TV. We use it as our main development platform, and it's been really great for us, which was kind of unexpected. But here's why we use it. For one, they're cheap. Everyone can have one or two. They can have one at home and one at work instead of trying to get dev kits from Xbox or whatever. They're portable. We make party games. It's important to test them in different groups of people in different places. And Fire TV is great. You just take it wherever you want. Tooling is easy. It's Android. Android apps are very easy to make. And it's a pretty open platform, so it's very easy to add features. You know, we have like a package manager that we have on Fire TV to get updates automatically over the air. It has a USB port, which is great. You can plug in a keyboard. That's handy when making console games. And we're developing anyway for it. It's a great release platform. It's a great target platform for our games. People love playing that, and there's a whole audience for our games, our casual games, that are never going to buy an Xbox One or a PS4, but they might buy a $150 box or a $99 box to play games on, and so we want to reach those people too. It's a dream product. Someone tweeted, a dream product idea, a small portable HDMI stick that is just powerful enough to store and run all the Jackbox multiplayer games. Well, hey, it exists. Just go buy it. We don't have to make it. And finally, it's been successful. All of our games are in the top 10 grossing list, and so that makes us happy and keeps us in business. So we're big fans of Fire TV. Now I'm going to turn it over to Mike, who's going to talk a little bit about how we use Twitch.
Thanks, Evan. So in making our games, we don't have large development budgets. We're a small company. We also don't have large marketing budgets. They're typically zero. So we rely very heavily on PR and word of mouth and any kind of virality we can get out of the web or out of social media. And building an online multiplayer is hard. Leveraging Twitch is easy. If we wanted to do real-time multiplayer, we have to have lobbies. We have to have the idea of host migration if somebody pulls out of the game. If we use Twitch, it kind of comes for free. And if our games can accommodate it based on the delay or the lag, which many of our games can, it actually works really well for us. And chat can be a secondary way to play. People are already interacting with the streamers, so they might as well have a way besides just chatting with the streamer to interact with them within the game. And we found that loop to be very compelling for the streamers. And it's just a new way. It's a new way to interact. Having 10,000 people play is very different than having an MMO or some other type of game where you have many, many people. It's pure entertainment, basically. So we're focused pretty heavily on the Twitch aspect of our games. With the audience members actually influencing the game, this is a shot of Lyric when he streamed, and you can see we had 4,000 or so players in their game, which is great. And it comes with some challenges on the development side, as Evan kind of pointed out. But we learn from those, and we build on it. But going forward, we're looking at additional ways to have the audience interact. We want to somehow integrate maybe with Twitch or with our own type of login or sign-in, the idea of audience scoring, the idea of leaderboards and competition. Find a way, perhaps if it's an 8-player game, as the core players, and then it supports 10,000, maybe there's a way to promote somebody into the game. If somebody falls below a certain threshold, and then one of the audience members can join and get promoted into it. Think kind of 1 versus 100, that type of play. And we can track and manipulate all the statistical information. There's certainly a lot of stuff going on in this realm. We have connectivity to every one of these devices. We have analytics, but they're fairly simplistic right now. We could certainly target and redirect our types of games a little more effectively by digging into the stats. And right now, audience members participate, but they do it anonymously. Only the players within the game actually get their user-generated content up there. And we're thinking of ways to get audience members to actually promote and get stuff up there. I mean, the challenging thing with that is there are always kind of trolls out there, and there's always people that want to do terrible things. And that kind of leads into more tools for the host. Potentially the ability to ban or somehow kick people from the game, an option to filter terrible racist or profanity, and provide codes to join the game, or private codes to join the game rather. So a streamer, right now if they put the game up, which is kind of what we did here when we just played, we quickly started the game before we shared the screen from the game, because anybody here in that moment could join and actually be a participant in the game. And in this case, we didn't want that. Some streamers also don't want that. They want to restrict it to just the handful of people that they want in the game, because again, some people do terrible things. We're considering more than 10,000 people. I mean, you could imagine an environment like a stadium or an arena or something where there's 40,000 people playing in the Jumbotron. Instead of guessing if the donut's going to beat the coffee cup running around, you're actually interacting with that on the phone. And these are avenues we're pursuing with this technology. And then obviously reduce the latency both within our own systems and ideally in the streaming networks. There's been reduction from a 30-second lag to 15 or 10 in some cases with Twitch. There's lots of optimization that can continue to come to improve this experience. And then crazy stuff. One of our games right now in the party pack is called Drawful, and you use your phone to actually draw pictures. And it's called Drawful because they're meant to be awful drawings. We don't give you a way to erase anything, and they typically become very funny and ridiculous type things. And if there was a way within the game in that moment to say, buy this on a t-shirt, that would be pretty powerful and pretty cool, and it kind of reinforces some of the stuff that Amazon's doing with their merch stuff. So we're looking forward to maybe doing something like that on future stuff. All right. Oh, this is back to you.
Well, I just wanted to thank you, first of all, for giving us this great insight into Quiplash. Really interesting. I love hearing about the architecture, and I also really loved the quote about the Fire TV stick. That's a winner for us. But I also wanted to leave you guys with some next steps. Number one, get Quiplash. It's a great game. It's super fun to play. Also, bring your game to Fire TV if you haven't already. Like you said, it's an Android platform. It's got a controller. It's got a lot of great features going for it. And then also, Mike mentioned, he was talking about how he's trying to, or Mike and Evan both actually, trying to reduce the barrier to entry for players and get them in the games. We'd like to suggest that you give Amazon Underground a try because it's a way for you to basically eliminate all of the selling that you have to do to get your customers to contribute to your bottom line, and it gives them free content while you guys get paid for actual engagement that you drive. So please take a look and give it a shot. And thank you so much for coming. There's some links up here that you can use to get in touch with these guys. And I also want to just remind you to, I'll put that back up, but I want to remind you to please fill out your evaluations. And, whoa. Whee. I just pushed it once.
Let's start over.
Yikes. Okay, sorry about that. There's a link at the bottom here too. The bit.ly App Store giveaway is where you can find out if you won one of the Fire TV sticks or a Kindle tablet or maybe even an Amazon Echo. So thank you so much for coming. I hope you enjoyed their talk.